Alright, so this is my Audi RS3. It's not stock, I've actually done quite a lot of work to it, but the best thing that I've done to it by far is under the hood. There you'll find a massive carbon fiber air intake from a company called Eventuri. The reason that I went for that one specifically is because it has the largest diameter tubing and the smoothest paths for airflow. In other words, it provides the least amount of restriction to that turbo 5-cylinder engine. And yeah, after I installed that thing, I mean, the difference is just insane. And it got me thinking, why is there nothing like this but for PCs? And I don't mean turbos or carbon fiber, but at the very least, how about some just proper directional airflow? Like, this is a pretty typical mid-tower PC. We've got a couple intake fans at the front, pointed generally at the stuff in the middle that we want to cool. Then we have some exhaust fans on the other side to extract that heat. But when you really think about it, the airflow in here is just kind of a mess. I mean, it's somewhat intentional, I guess, but a lot of it is just brute force. So what would happen if we fix that? So what we're talking about here are dedicated airflow paths. And taking some design tips from the Eventuri intake, I want these paths to be as large and smooth as possible. If a fan is meant to be cooling a component, I want 100% of that air to make it to that component with minimal restriction. Essentially, we're making a custom intake and exhaust for our CPU and GPU. Now at this point, I am pretty familiar with 3D modeling in Fusion 360, but man, I've never modeled anything like this before. So let's start with something that I do know how to do, and that is just model the PC build using some pretty basic shapes. So just by measuring up the case and then extruding boxes, we can start building up the exterior and interior of the NZXT H5. And yeah, it is pretty straightforward, but the measurements here do need to be really spot on. If I make a mistake by just 2 millimeters, that means our fan ducts will also be off by 2 millimeters. So I really made sure to double check everything, get all of those measurements super dialed in. Then I just added the massive CPU cooler and the RTX 4090 FE. No need to go overly detailed on those, just the correct dimensions and basic shapes should be enough to hopefully get our fan ducts modeled correctly. Now as for this specific build, we've pretty much gone with the most power-hungry hardware that you can possibly go with today. We've gone with the 24-core 13900K from Intel and the RTX 4090 FE. We also have 2 intake fans at the front and another one at the bottom. It's one of the cool things about the NZXT H5, and we'll definitely be making use of that. And we also have 2 exhaust fans at the top. I've also thrown in the new Deepcool Assassin 4 to cool off the CPU. Seems like a massive CPU cooler and one of the better options that you can buy today. But the main reason I went with this cooler is take a look at how closed off it is. Air goes in, air goes out, and that's it. There is no air escaping this thing at all. So hopefully that means it works even better with our custom intake and exhaust ducts. As for actually making those fan ducts though, I mean, I honestly have no idea what I'm doing. I've never 3D modeled anything like this before, but I knew that there were some functions hiding in Fusion 360 somewhere that would make it possible. And I ended up watching a bunch of tutorials on how to make intake and exhaust manifolds for engines, which is kind of like a complex version of what I want to make. In the end, I learned that there were 2 functions that I needed. Loft, which bridges 2 faces together, and then shell, which hollows it out. And that's it. As long as I had the correct dimensions of each face, I could quickly and easily make these fan ducts. So for the CPU cooler, I made one that intakes air from the top. It mounts to one of the 140mm fans at the top there, which funnels cool air directly into the heatsink. And then on the other side, we have another one which channels all of that hot air outside of the case. This way, we don't actually have to worry about the GPU heating up or the ambient temp inside the case warming up. The CPU cooler will always have access to cool air no matter what. Now to bring these models to life, we need 3D printing. And yeah, we have a lot of 3D printing to do. These are easily the biggest 3D models that I've ever printed. Even on my Bambu Lab X1 Carbon, which is one of the fastest 3D printers that you can buy, this footage is not sped up. This thing is actually insane, but still, the massive CPU intake here took over 6.5 hours to print. Luckily though, no failed prints at all, and the intake and exhaust here turned out exactly as I had planned. Now most of the stuff that I've 3D printed previously are just really small objects, things like water cooling pump brackets and stuff like that, but seeing something this big come to life is just something else completely. I mean, it legit looks like an engine part. If a wasn't made out of plastic, of course, but yeah, the print quality came out perfect, and the dimensions as well are pretty much spot on. I mean, the CPU exhaust bracket is pretty much perfect. The fitment there is super flush. This intake part, on the other hand, there is a small gap between it and the cooler, but I mean, honestly, I think it's close enough to keep moving forward. The GPU vents, on the other hand, are going to be much harder, and that's because the GPU intake vent needs to be massive. The plan here is to channel all of that cool air from that bottom intake up towards the 4090, but as you can see, it's pretty big. Too big, in fact, for my 3D printer. So I actually need to split this one up into two pieces, print them separately, and then join them together. This one as well doesn't really have any areas for mounting, so the plan is to just use double-sided tape. Now, one side of the 4090 FE cooler design is a blower, so our airflow there is taken care of, but we do need to make a vent for that exhaust fan. And for this one, I did experiment with curved paths, which would allow us to make a curved vent, but to be honest, it just didn't look that great. For this one as well, we do need to make enough clearance for those memory DIMMs and even that 24-pin cable, which does poke out a bit, as well as work around that massive CPU vent. So yeah, this GPU exhaust was definitely the hardest of the four. But in the end, multiple hours of 3D modeling and 3D printing later, the remaining ducts are ready to be installed. And the look of the build as well is super unique. It gets me excited because this is mostly a performance upgrade that I'm after here. I mean, man, take a look at the inside of this thing. There is like no empty space at all. You can feel the difference too. Like if you put your hand on like an opposite side of a vent, you can like really feel the amount of air that is being pushed out now compared to before where there was like not much air pressure at all. As for the performance, well, it's interesting. So Cyberpunk 2077 here at 4K ray traced ultra settings. That 4090 is really getting a workout, pushing above 400 watts consistently, and without our intake and exhaust vents, it sits at about 75 degrees. Then with the vents, we end up dropping 8 degrees on average, as well as dropping about 200 RPM on the fan speed. That is a massive improvement. And again, all we've done here is channel the airflow where it should be going. The case fans were 1000 RPM for both tests, and the room temp as well was 22°C. 8 degrees, man, that is a pretty big difference with a noise reduction as well. When we take a closer look though, things get even more interesting. We have an 8-degree drop on the GPU hotspot as well, 84 down to 76, and the memory temp, that dropped by 10 degrees, 87 down to 77. And again, that's with an actually lower GPU fan speed, which is kind of nuts. So with our 4090 now running in the mid 60s, that's actually only a couple degrees warmer than what you'll see on an open test bench. Those temperatures in a glass mid-tower case are simply unheard of. So I'd say mission accomplished. Except for when we look at the CPU. Despite seeing massive drops on the GPU, our CPU basically didn't see any drops at all, both in our gaming stress test, as you can see it's pretty much within margin of error, but also even in isolated tests like rendering. And I really thought that by creating these fan ducts that we'd be able to avoid the CPU cooler sucking in all of that warm air from the GPU, but it doesn't really seem to have made any difference. This really bothered me, so I ended up playing around a little bit more. I ended up flipping the remaining 2 case fans, so now we have a complete top intake front exhaust setup, and also played around with the fan speeds a little bit too. I increased the speeds of the fans that are attached to the fan ducts, and then dropped the speeds dramatically for the other 2 that aren't really doing anything. And this actually solved the problem. I guess previously there was like hot air recirculating back into the CPU cooler vent or something, because now our CPU temps on average get a 10-degree drop. What's more impressive though is that our hottest CPU core previously, also known as the package temp, that was hitting 100 degrees. Pulling in all of that GPU heat made it a bit toasty, enough to actually trigger thermal throttling and lower clock speeds. Now though, that hottest core is in the mid 70s. That's at the same CPU cooler fan speed, 1200 RPM for both tests. Now with this top intake front exhaust setup, we do see a small increase in the GPU temp. It's an increase of about 2 degrees, but it's a worthy trade-off to keep our CPU much better off now. And I mean, we're still 6 degrees cooler than stock with lower GPU fan speeds, so it's a much better configuration all around. Now I'll be the first to say that there are obvious limitations to this setup, right? It only works with this set of hardware currently, and if I want to use this in a different system, I would have to redesign and reprint all of these fan ducts, which is not really a viable solution. But I think more than anything, this really goes to show how bad regular PC airflow is. Like, in most cases, you have fans not really doing anything, you have airflow just generally getting really mixed up, and in almost every single mid-tower case, you have a GPU which is directly heating up your CPU. And it seems like the industry-accepted solution to this problem is just mesh. Just make the entire case mesh if you want, just brute force airflow, keep that interior temperature as low as possible, and that kind of just brute force fixes everything. This solution, though, disregards interior case temperature completely. The air goes in, is funneled directly into the heat sinks, and then it's ejected out immediately. It did also take hours to design, days to print, and only works with this CPU cooler, this GPU, and this case currently. So yeah, obvious limitations there, but the performance, it is on a different level.